Alright, this video is if you missed the lesson on inequalities, or this video could also be used for a review of inequalities before our assessment. If you are watching this video for the first time and did not take notes on inequalities, please make sure you get some of these notes down in your notebooks. So we started in class with the question, what is an inequality? And we kind of looked at the root word of inequality being equal. And then a lot of us decided that that prefix in made us not equal. Okay? And there's a lot of words that kind of go with that. Inconvenience, inability, inactive, lots of words that we talked about that had in as that prefix that made us not equal. So this is going to be not equal is an inequality. The actual definition of an inequality is a relationship between two expressions that are not equal, but instead one is greater than or less than the other. So we have four symbols that can express inequalities: greater than, less than, greater than or equal to, and less than or equal to. Notice that these bottom two symbols here have a small line underneath of them. That's half of an equal sign expressing that equals part of the equation. You'll also notice that we have a note here that says open circles and closed circles, and you'll see that when we go to graph our inequalities. Learning target number 3 is to graph solutions to inequalities on a number line. So we're going to go ahead and look at some number lines. This inequality says x is less than 7. Okay, so we talked in class that x could be 0, because 0 is less than 7, 2 is less than 7, 4 is less than 7, 6 is less than 7, 8 is more than 7, so we know we're not going to have 8. But let's get closer to 7 here. Can x be 6.5? Well, 6.5 is less than 7, so yes. Can it be 6.8? Can it be 6.9? Can it be 6.99? Yes. It cannot be 7 because 7 is not less than 7. So when we do not have an equals under our inequality, we put an open circle at 7 to express, okay, it can come up to 7, but it can't equal 7. And then we just put an arrow down towards all the numbers that are less than 7. Our next inequality is x is greater than or equal to negative 1. So some numbers that are greater than or equal to negative 1, 0, 2, 4, 6, obviously all these on the right side of our number line here. And then also in this example, x can equal, because of this little equal bar, x can equal negative 1. So we're going to put a closed circle at negative 1 and an arrow pointing upwards to all the numbers that are greater than negative 1. Let's try one more. Let's try x is less than or equal to 6. On a number line, I like to just put the number that we're at, and then maybe on either side put a couple more numbers just to give whoever's looking at our number line a better picture of where we're at. Okay? You don't have to write out a huge number line, but you do need at least 3 numbers so we know where you're going. This value says x is less than or equal to 6. So since we can be 6, we have a closed circle, and then we're going less than or equal to, so we're going to the left because 5 and 4 are less than 6. Learning target 4 says apply knowledge of inequalities to real-world situations. So we have a couple of real-world situations that I want to write inequalities for. This one says the temperature this week has been under 30 degrees every day. Some keywords that I want to pull out from that are temperature, under, and 30 degrees. If we look at this, temperature is what's changing each week. Some days it might be 20, 22, 24, 28. So I'm going to express our temperature with a variable t. 30 is obviously our number that we're going to use here. And then under is the word that will tell us which inequality to use. So we have to think, does under represent less than, greater than, less than or equal to, or greater than or equal to? Well, I think it's going to be either less than or equal to, because under seems smaller. Okay? But does under allow us to have been 30? Is there a day that could have been 30 if all the days were under 30? No, because under just means below. So we're going to take and say that t is less than 30. So if I put a quick number line on here. I'm going to have an open circle at 30 and an arrow going to the left because 29 is less than 30. Let's try another one. Every student scored higher than 60% on this test. So if we take out some keywords here, student score, higher, and 60% are what I'm looking at. Okay, so the student score, let's call it S, is higher. I'm going to say that's greater than 60%. And then go back and think, could it be 60%? No, higher just means above. So we just have higher. So 60, let's put 61, 59 on here. We're going to have an open circle at 60, and we're going above 60. So 61 would be above 60. Last one, Bobby and Sally are eating cookies. There are 20 cookies in the package, and Bobby ate 6. Write an inequality for how many cookies Sally can eat. Well, let's start off. There's 20 cookies in the package, right? So that's our total. We've got cookies that Bobby is eating, cookies that Sally is eating. And we know Bobby ate 6. All right? So before we even deal with how many Bobby ate, we know that we have 20 cookies, and that's the most anybody's going to eat. And they could eat all 20. So I'm going to say we could have an equal sign there. And let's let Sally equal S and Bobby equal B. Okay, so we got Sally and Bobby here. The cookies they eat have to be less than or equal to 20. Alright, and so now I'm just going to put in what we know. We know Bobby ate 6 cookies. Okay, so 6 cookies plus whatever Sally eats has to be less than 20. I could also write that as the 20 cookies that are total minus the 6 cookies Bobby ate has to be greater than what Sally can eat, greater than or equal to. And then if I actually do that math, 20 minus 16 or minus 6 is 14. So Sally can eat up to 14 cookies. So if we put 14, 15, 13 on a number line, close circle at 14, and she can eat all the cookies less than that. That is our video on inequalities. If you have any questions before the assessment, make sure you ask your teacher for some more help.